Hey, let's take a look at the volume of a cone today, which should be pretty straightforward since you already know the volume of a pyramid, which is the area of the base multiplied by the height divided by 3. Now you can think of a cone as being a circle-based pyramid, so we can just say that that's pi r squared multiplied by h divided by 3. But let's have a look at a couple of examples. Now, first of all, I want to bring us back to the whole thing that we did on similar shapes before. When we were talking about similar spheres, any sphere is similar to another sphere regardless of the size. That is not the case with cones, because with the cone, it's not just one measurement that you have in mind. You're not just thinking about what the radius is, but you also have to think about what the height is. Or sometimes they talk about this diagonal length that goes from the circumference up to the top point there. Okay, so there's 3 different measures that you could take into consideration here. Really, with these two, the length is intended, but you need to consider everything. And if it doesn't say that it's similar, you can't just assume that it's similar. All right, so let's start with one example where I'm not going to tell you what the radius is and what the height is. That would be too straightforward. Although in the exercise, a lot of the times they will tell you what the radius is, what the height is, and you just substitute it into the formula. But for this case, I'm going to tell you what the radius is and what the length is going up the side. And from there, you could definitely work out what the height was. So given r is equal to 5 centimeters and L is equal to 10 centimeters. Okay, in this case, we don't know what the height is. We can't substitute directly into there. I could do pi times 5 squared multiplied by, I need to work out what that is first. So over here, I'm going to work out what the height is. I know that the height and the radius make a right angle, and the length up the side, that should make a right angle triangle, where that's the hypotenuse. So I'm going to go ahead and use Pythagoras here. A squared plus b squared equals c squared, where the radius squared plus the height squared is equal to that length squared. Okay, so substituting into that there, I've got 5 squared plus h squared equals 10 squared. So h would have to be 100, which is the 10 squared, minus the 25, which is the 5 squared, square rooted. So that's going to be the square root of 75, which of course I'll need a calculator to work that out, but I'm always going to work with exact values right through till the end, so I'm just going to keep that as the square root of 75. Okay, now that I've got the height and I've got the radius, I can go ahead and use the formula. V, the volume of the cone, is equal to pi times the radius, which is 5 squared, times the height, which is the square root of 75, over 3. Okay? And then I just need my calculator for that. That's going to be, basically, that's going to be 25 times square root of 75 pi. Oops, that square root sign's not over the pi, and that's really important as well. That you make sure you know where your square root sign stops. Okay, because we don't want to square root things that we don't intend to, nor do we want to leave things out that we did intend to square root the whole thing over 3. Okay, so just going ahead and multiply that out. Yeah, 25 times the square root of 75 times, and I'm checking my calculator. My calculator doesn't have that square root sign that goes over the pi as well. In fact, I might just work that out first and then multiply the pi separately just to make sure. That 216.5 pi over 3. Okay, so V equals 216.5 pi over 3. Okay, so now I'm sure that I've got the exact value because I'm keeping working with my calculator. Times that by pi divided by 3. And my rounded answer to 3 significant figure, that would be 227. Approximately 227. And this was in centimeters. This is a volume, so my units are centimeters cubed, and that's to 3 significant figures. Okay, so I wanted to give you one where you have to do a little bit of working first, but basically I just need to do the radius squared times by pi times by the height that we worked out divided by 3. Pretty easy and straightforward if you're used to using the pyramid formula. Right, for example 2, I'm going to give you a bit more of a challenge in terms of the amount of work that you need to do, but I'm going to give you really nice numbers to work with. Starting out with this, I'm telling you what the circumference is. So I'm not telling you what the radius is, but I'm telling you what the circumference is. So you're going to have to do some work to work out the radius, but I've given you really nice numbers to work with here because I told you the circumference in terms of pi. So that's going to simplify really nicely. So let's start with that. I told you the circumference, I told you the length. So I've told you this length here up the side. It's not the height of the pyramids, or sorry, not the height of the cone. So I'm also going to have to work out the height, right? And the radius. So here, really easy formula. We know that the circumference is 2 pi r. And I've told you that for this particular cone, the circumference is 6 pi. So 2 pi r is equal to 6 pi, which means that r on its own, moving all of this together, because all of this is multiplying by r, I can take it together and divide. So I do 6 pi divided by 2 pi. Top divided by 2 will be 3 divided by pi. The pi is going to disappear, right? So the pi's, because I've got pi's on top and bottom, I'm dividing both top and bottom by pi, and it's gone. So that just gives me the radius is 3 centimeters. I told you I gave you some nice numbers to work with. So the radius is just 3 centimeters. Now, for the height, I know the length, I know the radius, and I know that that's going to make a nice right angle triangle. Right, so I'm going to use Pythagoras here. A squared plus b squared equals c squared, where the longest side is this hypotenuse length, which is the 5, so 5 squared. And then I'll substitute in the radius here, so 3 squared plus whatever that height is squared is equal to 5 squared. Now the reason this works out so nicely, I chose these numbers carefully, is because when I rearrange this, I end up with height is equal to the square root of, now the 5 squared is 25, minus the 3 squared is 9. That gives me the square root of 16, which hopefully you know your square numbers well enough. That is a square number, so it square roots perfectly to make a whole rational number of 4. Now that does not happen often, but I'm going to tell you right now, I did that on purpose because I happen to know that 3 squared plus 4 squared equals 5 squared. That's a Pythagorean triple. Pythagorean triple. And that's something you're going to see a lot of if you ever get to math at A level. They used Pythagorean triples very often to describe different angles. Rather than telling you the angles, they tell you a relationship between the sides. So they often use whole number sides for that. Okay, so that aside, I've got my radius, I've got my height, I've got a really nice easy formula here. Volume is equal to the area of the base, pi r squared, multiplied by the height, divided by 3. So the volume is equal to pi times 3 squared times by 4 over 3. Okay? V is equal to, now you could simplify this ahead of time. If I see I need to multiply by 3 twice, and then I'm going to divide by 3 once, I could actually just cancel that out and say that's going to be pi times 3 times 4. But if that's too much of a stretch for you, let's just work this out. So it's going to be pi times 9 times 4 over 3, and that's going to end up being pi. 9 times 4 is 36, divided by 3. Pi times 36 divided by 3, 36 divided by 3 is 12. So that's 12 pi. And remember what I said up here, if I'm going to multiply by 3 squared and then divide by 3, I may as well just cancel that out and say that that's 3 times 4, 12. It's 12 pi. Okay, so my volume, this was in centimeters. My volume is a 3-dimensional measure in centimeters cubed. Now that is exact. If I need to work out my answer to 3 significant figures, that's going to be 12 times pi, 12 times pi, 37.7. Approximately, I have to round that, centimeters cubed. That's to 3 significant figures. Okay. Right, now our third example, I'm going to make it just a little bit more challenging. Now I'm telling you what the volume is and what the height is, and I want you to work backwards to find out what the radius is. But just like we did in example 2, where I told you what the circumference was, you could work out what the radius was, and then you could work out the volume with that formula. Okay, so we're just going to use the volume formula to work out what the radius is. I've got the height already. I'm going easy on here, so we don't need to use Pythagoras. This is not the length down the side. This is the actual height. So V equals pi r squared times the height divided by 3. And I'm told that that answer is 30 pi. Okay, so I want to work out what the radius is. I know what the height is already, so I'll just go ahead and substitute that in. That's going to be 10 pi r squared over 3. Now you might be a little bit confused about me changing the order there. It's just because I like to put the numbers in the front and the variables last. So I've substituted the 10 in for h. and I put that in front of the pi. So 10 pi r squared divided by 3. Now rearranging this, I can see that everything here is being divided by 3, so I can take the 3 across and multiply it. So 30 times 3 is 90 pi. Leaves me with 10 pi r squared on this side. R squared on its own, I can take all of that together because all of it is multiplying by the r squared. So take it to the other side and I'll divide by it. So that's 90 pi divided by 10 pi. And that works out really nicely. Just to the pi divided by pi cancels out. The 90 divided by 10, that just works out to be 9. So r squared equals 9. R must therefore be the square root of 9, which we all know is 3. Now this was in centimeters. The volume I didn't give a unit, but that must be in a squared unit of, or sorry, cubed unit of measure because volumes are 3-dimensional. So that must have been in centimeters cubed. If it weren't, I would have had to do some kind of conversion before I did all of that. So if that's in centimeters cubed, that's in centimeters. A radius is just a length. It's a one-dimensional measure. It must be in centimeters. Okay, and that's exact. I don't need to say to 3 significant figures. I don't need to do any little rounding symbol on there. Okay. So hopefully that works out well for you, and just let me know if you need any help.